Alright, so if you pause right here, you can check your work on today's thing with 3 twisting forces down, 1 twisting force back up, and you can do this. It'll make sense why I have so many things on the clockwise and only 1 on the counterclockwise. And after you find that, after you find your RCY, you can find Ray, you can find Rax because there's no left force. And then how do you find the angles? You have to see the triangle. Like if I'm going after angle A here, I have Y is, the height is 3 and the base is 3. And some of you guys know that's a 45-degree angle. If not, you could do inverse tangent of Y over X and get 45. And then RC, angle C is symmetric, so that's a 45 because it's 3 high and 3 over. The other 2 angles, I named them angle 1 and 2, so I didn't have to do that other thing. Do you see this triangle? You have a height of 3 and a base of 2. So when you do inverse tangent of 3 over 2, you get 56.3. And then symmetry works. So after you got all that good stuff, your next step is to draw the free body diagram. Okay? The free body diagram is like drawing the original thing. I do it in pencil because I draw the original picture and then I erase all the middles. So we're going to draw, kind of looks like this. Right? Something like that. And then it goes down like this. Boom, boom. Okay. So we have A, B, C, D, E. Okay. So we'll go A, B, C, D. Oh, wait, which one's D? Yeah, D, E. So I'm going to pause and draw this and then let you look at it for a sec. Okay, so I drew the picture, I erased the middles, and then we can actually figure out which way the arrows go. I'll walk through this one more time with you. If this is pushing up, the only thing that could fight is this guy pushing down. And we do the whole equal and opposite force thing. If this is pushing left and down, then the only thing to fight it would be if this guy pushed right. Whole equal and opposite force thing. I can go over here and do the same thing. That's pushing up, this must push down. That's pushing right and down, this must push left. Equal and opposite, right? Newton's law. And then we go up here. This is a little debatable because you got a down and an up. And I don't know which one of these is pushing left, but I do have these. And if there's a down, then some of these have to be pushing up. Remember, if you drew them wrong, it's not the biggest deal in the world. But yeah, so we'll figure that out. I'm going with up on this. It's my best guess. Now these are pushing right, which means that guy has to push left, equal and opposite. And then this guy might be pushing up, it might be pushing down. I'm going to go with up for now, and we'll figure it out later if it's wrong. So the last thing on here is to label this FAD, force on AB. This is the force on DB. This is the force on DE. This is the force on BE. The force on CE. And the force on BC. Lots of forces going on. Okay, so now it's just a whole festival of the ups equal the downs and the lefts equal the rights. And you got to pick one joint at a time. My suggestion is pick A first. Okay, and if I pick joint A, then I'm going to I'll draw it, right? So joint A, we got FAD fighting down. We got FAB fighting right. We got 975 going up. And a 45-degree angle. Okay, so what's nice here, I don't want to go after FAB first. I always go after the diagonal first because my up force is only fought by the down force of FAD. Problem is, if you put 975 here, you don't want to set it equal to FAD. You have to turn it into a downforce by doing diagonal times sine. And then just divide both sides by that, because sine turns it into a vertical force. Right? So FAD is going to be whatever 975 divided by sine of 45 is, which happens to be 1378.86. Then we use that answer to find FAB because part of this force is pushing left. I just found the diagonal force. So now my force left has to equal my force right. So my force left is take that diagonal, multiply it by cosine of the angle to equal out my right force. Now, why didn't I have to use cosine on this? Because it's not a diagonal force, it's just straight right. So I just take that guy, my last answer, 1378.86 times cosine of 45, and I get 975. Ooh. Does that make sense? I think it does, because, gosh darn it, because it's a 45-degree angle, so your up and right force should be the same. So this one's 975. This one's 1378.86. And then you go after another joint. Guess what joint I picked next? I'm staying away from B. I will never go to B. It looks too crazy. C looks okay. Now don't think you can already write the answers in for joint C, because you don't know enough about, or it's different. You can't say symmetry because it's a different force than on the other one. I have 775 here. I have FCE here, and I have FBC here. Right? So, and I have a 45-degree angle. So, if you use common sense, that's probably going to be 775. But let's do it in the order we should, because I won't always have a 45-degree angle. So this one, the down force has to equal the up force. So my down force is diagonal times sine of my angle. That has to equal my up force. And then divide. And you'll have FCE equals, I'll do that on my calculator, we get 1096.02. And then I can do my lefts equaling my rights by taking my left is FBC. I don't need to use trig because it's a straight left force, it's not diagonal. And then I can turn that guy into a horizontal by doing cosine 45. And you get 775. You'll type it in your calculator, and rounding, you get 775. Okay. Now we're making some progress, because I got this and this and this. So what you need to attack next is I would go after D or E, because I don't want to go after B. So you draw D out and see what you have. This is probably the hardest step. So I'm going to draw D, joint D. Okay, and joint D has, here it is, and I got the 1378.86 going up, and then I have the 1,000 pounds straight down. Oops, 1,000 pounds. And then I have an in force to fight the left force, and that's named FDE. And I have the down force here. Now this might be wrong, the down force. We're going to find out in a second. But it's labeled FBD. Okay, so I have this guy. It's also important to know this is a 45-degree angle, and down here is a 56.3-degree angle. Okay, so my first inclination is to do the ups and the downs, because I like to. And I have one up force and two down forces. We're going to find out if I drew that arrow wrong, because it comes out negative if I drew it wrong. So I have one up force drawn on my picture, and that would not be 1378. It would be 1378 times sine of 45. That turns it into an up force. And that should equal my two down forces together, 1,000 pounds and FBD times sine of 56.3. That turns it into a vertical force. And what you're about to see is whether or not I did it right. So I use my math skills. I subtract 1,000 from each side. So let me do 1378.86 times sine of 45 minus 1,000. And you see I have negative number. This is not good. I mean, it's not the end of the world. Let's call that negative 25. And then I divide it by sine of 56.3. I'm breaking pencil all over the sine of 56.3. And I'll take that. So negative 25 divided by sine of 56.3. And I get a negative 30.05 for FBD. Now that doesn't mean it's negative. It means it's positive. It just means I go back up to my picture and I realize I made a mistake and it must be the other direction. So it's not a big deal. Remember, don't stress out about that. It's actually going up and to the left. So this is a 30.05 pound force. Now that's going to be helpful. I'm going to change it on there, and I'm changing it on here. My arrow's going up. Oh, did I do the equal and opposite thing? No, I didn't. Ooh. So that one's up, this one's down. Okay. So, with that in mind, I'm going to change this for my left and right thing. So I'm going to make it a positive. You can do that since I switched the arrow. Now my force left has to equal my force right. Okay, so how many do I have moving left? I have FDE. I don't need trig on that because it's straight left. And I have this guy's push left, which is 30.05, but it's on a diagonal. So I'm going to say 30.05 cosine 56.3. And that has to equal my right push, which is this guy, but since it's at an angle, I use cosine of its 45-degree angle. And a little subtraction later, right, you're going to take this guy minus this ugly thing, subtract 30 cosine 56.3 from both sides, so 1378.86 cosine 45, enter parenthesis minus 30.05 cosine of 56.3, and you get 958 for FDE. 958.33. Okay, so we go up here, we write it in. Where was that? FDE. 958.33. And then you're going to do the same thing on E. So I'm going to leave joint E for you to do because it's very, very similar to what we just did on D. And if I don't know if these arrows are wrong, we're about to find out. They might be right, they might be wrong. Don't assume because that one was wrong, this one's wrong, because they're different weights. So they might be okay the way I drew them. Okay, so you're going to do that same thing. Try it with joint E. And then you'll be done because you'll have figured out the last two things you need, which are those two. Oh wait, I already know that. The last thing you need, that'll be even easier because I already know the right force is 958. And you can just do the left forces. So that should be easier. You shouldn't have a lot to do. Try that out. Hopefully that helps. See you later, people.